So this is a cylindrical polar coordinate system, right? This figure, but it combines all coordinate system in there, right? So whenever you have a problem um, in dynamics, the first thing that you need to do is to label the coordinate system, right? If you have a geometry, you have to know where is the initial frame of reference. So what you need to do first, right? Let's say I'm going to place origin as O, right? So no, let me change to the another color there so that you remember, right? So this is the first thing that you need to do, right? So you have to label uh, the origin first. Normally in the book they're going to assign label O at the origin, and then if we have a particles object that represent a point, for example, you can use A. If, let's say if you don't like to use P, you can use A there as a center of gravity, right? Center of ni, you can set A there. And you can also place another region of interest, maybe B, right? Or here you can place at C, something like that. So first you need to do is to label the domain. I don't know how can I make it make to remove all the text. I'm still learning, right? And then we need to look at the path of the uh, motion, right? So you can you can describe the problem in S coordinate system, or you can using the XY coordinate system, or you can use R coordinate system. Again, for the R coordinate system, it's very important that when you draw the angle, you should start from the line that represent the x-axis, right? From the x-axis, and then it's go positive in the counterclockwise direction, right? So this is very important. So make sure that this one is represent in that direction as a theta positive, and the R should be in that direction. The X will be in the positive direction, something like that. So this is a convention. You must follow this, right? So these vectors represent the positive value. Whatever problem that you have, you must follow this convention. But now it's a three-dimensional, so we don't solve problem in three-dimensional. It's so difficult. So we have to solve it in the two-dimensional plane, right? So this is what we will do in our lecture. Um, we're going to look at um, this the motion of the problem based on the experimental work, right? So we have high-speed cameras that interlace, right? Superimpose a different time. And then if you have this type problem, the first thing that you need to do is to assign the origin. Let's say, anyone want to assign the origin here? I give you opportunities. Where is the best position for the origin? Anyone? And then I give the authority. Oh yes, okay, Muhammad. Yeah, I'll give you authority. Now you set the origin and then labeling it. You just put a point, draw a point, and then label. Right. So okay, label, put label. Sabar je lah. Okay. Dah yang panjang, pendek dah. Sampai sini sekerat dah. Kan? Tak payah panjang. Sampai sini dah kan. Uh, and then draw whatever coordinate system there. Tulis kat situ. Guna T. Kan ada T situ kan. Ada text kan. T kan. Pakai T tu tulis. Okay, tapi letak kat sini lah. X. Coordinate X tu dekat sini. Ni you punya origin. You should label with O. And then you have X. So this one will be X. Tambah Y kat situ. I do cartesians. Letak Y. Letak kat sini. Jangan tak situ apa. Tak situ. Pandai. Okay. Right. Right. So dah cukup. Saya tak bagi authority dah. Kan? Bagi authority sekali lagi. Letak label kat sini. Muhammad. Bagi label O kat situ. Gerak kan ni. Alright, so that will be label O. So the position vector at instant, right? Apa benda mu'ad khamis, yes. Right, I don't know how to draw straight. So this one is the ni R at this instance. And if we want to draw in XY, so that should not be the case, right? So first we have this as the ni, and then the position there to represent X and Y, right? So that will be the Cartesian coordinate system. Now, if we want to write in the spherical polar coordinate system, so we have the different notation. So we have R there. No, let's say I'm going to go to another location. This one is R, and then this is the value of theta, right? And if we want to measure using S coordinate system, let's say start from here, so the coordinate system will be in that direction. They're using a different color then. So that will be the S coordinate system, right? So we just consider until that location, values. Now what color? I don't know what color is that. So we are measuring the S values, right? And then if we have a Tn, we have another coordinate system called NT coordinate system, normal tangent coordinate system. So for NT coordinate system, actually it's same like S coordinate system, right? So, and it doesn't give you, for position vectors, it will represent by the curvatures and the by the curvatures only. So there, let's say this one, right? So the radius, maybe that will be the radius, right? The origin will be somewhere here. So they're not sharing the same origin as the Cartesian coordinate system. So that will be the anti-coordinate system. So position vector should be from the origin of the case, right? Now we're going to look how we're going to define the velocity vectors. So velocity vectors will be defined at the center mass of the center of gravity of the body. For the apa ni velocity vectors, we will assign the velocity vector according to the at the center mass of the location, right? So that the velocity vectors, the actual velocity vectors in that position, and we can also assign the coordinate system for this case. So this one will be the Vx and that will be Vy, right? So this is the coordinate system for spherical polar coordinate systems. So if you want to draw it in for the cartesian coordinate system, this will be the coordinate system that you're going to use for velocities, right? So this one is Vx and Vy. So this is the how we define the velocity coordinate system, velocity vectors, and how we can draw the description of the motion based on velocities.